Hello, my name is Kiwano, and I'm going to present my project, which is based on dog versus cat classification using a four-layer convolutional neural network. Um, from now on, I'm going to show the recorded results in the my Jupyter notebook because trying to run all the code will take more than an hour, and I believe that's very time consuming. So let's start. So in the first input box, as you can see, I have imported all of the libraries that are necessary for this project. And now if we move on to second input box, here's just setting the directory path where I stored the data sets, and also I have set the required width and height of the image before, so that we can fix the image size for training. Here in the third input box, it's just unzipping the training at the test sets, and in the next, so here this is a function that reads the image, each image in the folder that we just unzipped, and tries to read the image using OpenCV, and also resize the image, as I said, 100 by 100, and then we try to make a big array or a big matrix, so that we can use those zetas to train through the convolutional neural network. So, and in this box, so here now we split the training set, which the 80% goes to the training set, and 20% will be the validation set. And here is just extracting the number of training sets and the validation set we have. Now this is the part where I've implemented the data augmentation, and these are all based on the convolutional neural network presentation that one of our TAs had previously. So and also now from in this input box, I've just tried to show a sample of what happens when we apply the data augmentation function. So in this left image is the original image, but just grayscale. But in the right, here is the like rotated and somewhat moved. So this is how we transform, the function transforms and makes data augmentation. Now, okay, this is the main part, and this is the model of the network that I've tried to make. And so it's just repetition of 4 convolutional layers, which each has 2D convolution, 1 max pool, and 1 batch normalization filter, and 1 dropout filter. And so this convolutional 2D, but as we can see in the ResNet, the number of convolution layers increases for each step. So that's where I tried to make some toy example of the ResNet. So the first layers have 64 convolution filters, but in the next two we have 128 convolution filters. So, and as we can see, this also shows how the network is composed, and we can see that after the convolution layers, if we flatten the data, it has 2048 inputs. So I try to match the flattened data when we go to the neural network. So these three layers are the neural networks, and we can see that the first two are the hidden layers, and this is the output layer, which is just one because this is a binary classification. And that's why I also used as the loss function. I used the binary cross entropy instead of categorical cross entropy, I believe, for multi-class cases. Okay, and in this box is where I trained the model above. So, and the epochs were set to 50, and this is just this 32 means the batch size, so this is the actual number of steps for validations, and this is for training sets. And we bring the data augmented training and validation set, and if we train it, this is the epochs that have been produced, and as we can see, the loss is generally decreasing and the accuracy is gonna gradually increase. So instead of looking at these results, I've tried to so here's where I tried to plot the accuracy and the loss of both training and validation sets, and as we can see, the loss have decreased gradually, and also the accuracy has increased correspondingly. And we can see that in the maximum state, it's almost at 95% accuracy. So we can say that this convolution neural network is kind of acceptable to test the data sets. But however, the labels for the training test images were not provided in the Kaggle, so I just tried to create prediction. I just tried to run the model with the trained weights and just try to predict the labels. So this, in the 57 input, it's where we get the predicted probabilities. So, but since the labels are integers 0 and 1, I had to round the predicted probabilities and change it to integers, and we can see that the predicted labels are a list of 1 and zeros. Okay, so this is it for my project, and this was very wonderful experience training a convolutional neural network and actually trying to classify real image data sets. Thank you.